All right, so what we are given for this one is this graph, and it says it's the graph of f prime, and I know that's really small, so I'm going to label this like bigger here. This is the graph of f prime, is what we're given. And those are all shapes that we can't find the areas of, but they just go ahead and tell them to us, which is great. Like you don't even have to do any work to find any of the areas. They just tell you what they are all worth. So that's really nice. All right, from 0 to 7, the areas of f prime are labeled. We're told f of 4 equals 10. That kind of got cut off there, so I'm going to write that a little bit bigger as well. That's an initial condition that we're given. So f of 4 equals 10. And notice it doesn't start at 0. Remember, I told you it doesn't always start, your accumulation doesn't always begin at 0. This time it starts at 4. It's whatever they happen to tell you. All right, and then they give us g of x. Again, I'm going to write this bigger because it's real small. G of x equals 5 minus x squared. So that's what we're given to work with. A lot of times you almost want to like ignore all the information they tell you and just kind of jump to the problem. I know that sounds backwards, but it's like they slam you with information and it's like they overwhelm you. So sometimes it's almost better to like read the question and then go back and see what you've got. All right, but we've got this graph, we've got an initial condition, and we've got g of x equals 5 minus x squared. So this says find the value of, and again, I'm going to write it bigger, integral 0 to 7 f prime of x dx. All right, this is the graph of f prime. So what they're asking for is the area under the curve from 0 to 7. So essentially they're just asking you to like add and subtract all that together. So it would be 2 and then negative 7. I know they say this area is worth 7, but it's below sea level. So that would be negative 7. So 2 minus 7 plus 3 plus 1. You do not need to total it. In fact, if you add it or subtract it and you just like do it wrong because you're just having an off day, your answer will be wrong. So you are so much better off just leaving it like that. And that's the answer. That's it. That's all you got to do. All right, letter B. Given that f of 4 equals 10, and they tend to do that sometimes. They'll tell you that in the problem, and they'll tell you that like then in part of the problem. So they told us that twice. Write an expression for f of x that involves an integral. All right, so let's go ahead and do that first. I know there's going to be more to this problem, but let's go ahead and start with this. This is f prime. They're asking for f of x. So it's going to involve an integral. And they even said that involves an integral. So our initial condition is 10. So it's going to be 10 plus, and then our accumulation. And the accumulation begins at 4. It's from 4 to x, from 4 to whenever, and then f prime of t dt, which is going to be this graph. Don't get hung up on the x's and the t's. I put t for this because technically if this is an x, you shouldn't have another x, like you shouldn't have them both be x. They're not going to mark that wrong though if you put x for the whole thing. I mean, for heaven's sake. Like, anyway, this is the expression. It's the initial condition plus the accumulation. The accumulation begins at 4. Right, so there's that. And then it says use this expression to find the absolute minimum. All right, when it is absolute maximums and minimums, what test is this? What do we call this test for absolute? Hint, you make a chart. What is this test called that we're going to do? No, we're going to need to play hangman. Hold on. Oh, there we go. Someone got it. I was going to play hangman to get you guys get it. Candidates test. All right, cool. Who are your candidates? And I'm not looking for actual numeric values here, just in words, like no matter what problem you're doing, who are the candidates that we're going to put on the chart? Good endpoints and good. I like how you say zeros. It's critical points, which are going to be the zeros of this graph. So perfect. It's where derivative equals 0. All right, so endpoints are 0 and 7. We're going to have a lot on this chart here. Endpoints are 0 and 7, and then our critical points are these zeros, so 1, 4, and 6. And the chart acts as your justification because you're testing every single candidate that's an option. Remember how to do it, I just don't remember the name. That's okay. Actually, they wouldn't ask you that, but I want you to know what it's called. All right, these are all your candidates. Because I feel like if you remember it's called the candidates test, then you'll go, oh wait, who are my candidates? Oh yeah, it's the endpoints and the critical points. All right, so we're going to plug everything into this expression right here. So these are all going to be 10 plus something. So this is 10 plus the accumulation from 4 to 0, we're going to plug 0 in for x. So if we go from 4 to 0, we're going backwards. So this would be a positive 7 and a negative 2. So that's going to give us 15 for that one. All right, and then plugging in 1. Again, all of these are going to be 10 plus. All right, if you plug in 1, going from 4 to 1, again, you're going backwards, so it's going to be a positive 7, so that'll be 17. If you plug in 4, the integral from 4 to 4 gives you nothing, so it would be 10 plus nothing, so it's just 10. And then for 6, we have 10 plus integral from 4 to 6 would be this amount right here, so that's 3, so 13 for that one. And then for 7, again, plugging in 7, we have 10 plus the integral from 4 to 7, so 3 plus 1. And so that would be 14. All right, and what did they ask for? The absolute minimum. Oh, it says and the absolute maximum, so we have to list out both of them. All right, so the absolute maximum is, what is the biggest result? We got 17 at x equals 1. And the absolute minimum is 10 at x equals 4. And those are your answers. The chart is your justification, so you don't have to say anything else about that. All right, letter C, find the integral of g of x. There are no boundaries, so this is just going to be get the antiderivative, put a plus c. We don't have any boundaries here. Now, g of x is this statement right here, this 5 minus x squared that they gave us. So what they're asking us for is the integral, the antiderivative of 5 minus x squared dx. All right, so the antiderivative would be 5x minus 1/3 x cubed and then plus c, and that's all you have to do for that one. Don't overthink. Not every problem is going to be super difficult. That's all that was asking you for, so that's all that you have to do. All right, and this one, again, I'm going to write it a little bit bigger so we can see it. Integral from 1 to 2 x f prime of g of x dx. All right, this is going to involve a u substitution. You have f prime of g of x. G of x is like the guts of the problem. This is the inside stuff. So we're going to let u equal that inside stuff, g of x, which is 5 minus x squared. That's what they told us g of x was. And remember, g is this 5 minus x squared. All right, then we're going to do the derivative of that. Let me throw that question at you. Hey guys, what is the derivative of this? That's something, that's an easy one. You'll be able to actually type that in the chat. So what's our derivative of this statement? Ooh, close. We do want the minus 2x. You're the only one that answered though, so yeah, good. The 5 is going to be a constant, so that's going to drop out. So good, it would just be negative 2x dx. All right, sweet. Now, how are we going to adjust that when we look at the problem? Because when you go to match this up, we have the dx, obviously. We have the x. What do I need to multiply this by for an adjustment? Because I do need to fix that. Yeah, good, sweet. All right, negative 1/2. So negative 1/2 du is going to equal x dx. Let me go ahead and highlight. Oh, I put my highlighter away. Hold on. So we're going to substitute in for the x dx. And in its place, we're going to put negative 1/2 du. So the negative 1/2 went out front. Du goes at the end. Whatever we didn't highlight is still there, which is f prime of g of x, and we're letting u equal that g of x. So it is f prime of u. And then I have to adjust the boundaries. It is easy to do, you just have to remember to do it. You're just gonna take this 1 and this 2 and plug them in for x. That is all there is to it, all right? So if you plug in 1, you're gonna have 5 minus 1, which is 4. And then if you plug in 2, 2 squared is 4, you're going to have 5 minus 4, which is 1. So you just have to adjust those. And now we're going to do the antiderivative. Now this is f prime, so the antiderivative will just be f of x, so which is f of u, and then such that 4 to 1. So the derivative of f is f prime. We just did that backwards. It was an antiderivative. All right, so we're going to do upper boundary minus lower boundary. So this would be -1/2 f of 1 minus -1/2 f of 4. And you do have to evaluate those. You can't leave something f of 1 and f of 4. They're going to want you to evaluate that. But I think we already did those in the table. We did so many values in the table. I'm betting we did those ones already. This would be -1/2 times f of 1, we got 17. And then minus -1/2 times f of 4, which we got 10. So you get to reuse work that you've already done. And don't simplify that any further. Just leave that alone. Because if you try to mess with that and drop a negative or something, then it's going to be wrong. So just leave it.